Hello, and thanks for clicking on this next Prenarculus production. Today we're going to talk about transformations of functions, which you learned back in algebra. Here's a chance to review all of your transformations and how they all work together to move graphs all over the coordinate plane. So let's get started and review all the transformations that we know or that we should remember, and then we'll go from there and we'll do some practice. Okay, so the graph of a function can be transformed by shifting it, moving it left and right, stretching it, shrinking it, or reflecting it, flipping it over the x-axis, flipping it over the y-axis, whatever it may be. So here are our transformations. A vertical transformation moves the graph up and down. We can find that transformation by taking the function and adding a value, k, or subtracting a value, k. If I add k, it moves the graph k units up. If I subtract it, it moves it k units down. The horizontal transformation moves the graph left and right. Remember, horizontal transformations, everything that involves x inside the parentheses is kind of backward. So x minus h moves the graph h units to the right, but x plus h moves it to the left. Okay, so those are the horizontal transformations. And then we have some reflections. So if I have negative f of x, so if I take y, right, f of x is just a fancy way to say y. If I take y and make it negative, all right, let's think about it. Here's a point here. If I take the y and make it negative, it flips it this way. So that's a reflection over the x-axis, okay? If I take the x and make it negative, so here's a point, take the x and make it negative, it flips it this way, over the y-axis, all right? We can also vertically stretch or shrink the graph by multiplying the function f of x by a, and we can horizontally stretch or shrink the graph by multiplying x by b, which again is going to kind of be backward when we look at it and try to work on that transformation a little later. All right, so let's get started with some simple transformations, and we're going to go from there. Okay, so let's use this function, f of x equals x squared, and we're going to write the new function after the given translation. All right, so in letter A, I want you to take f of x and move it up 3. So my new equation would just be take x squared and add 3 to the end of it. That moves it up 3. If I want to take x squared and move it down 5, I'd take x squared and subtract 5. If I want to take x squared and move it left 1, now the 1 has to go inside the parentheses with the x. But I want it to go left 1. So remember, everything inside is opposite. So x plus 1 squared, that's going to move my graph 1 to the left. If I want to move it 5 to the right, again, it has to go inside with x, inside the parentheses. Everything's kind of backward there. X minus 5 squared moves this graph 5 to the right. Now, if I want to combine them, I want to go 1 right and down 4. Well, that would be take x, subtract 1, and square it. That moves it 1 to the right. And then down 4, minus 4 at the end. If I want to go left 7, up 8, take x, add 7, square it. That's going to move me left 7, up 8, plus 8. Those would be my functions. That's what they would look like. Okay, you should be able to take given transformations and write the equation based on that given transformation that you've been told. All right. All right, now let's talk about how we're going to actually go about graphing these things. So what we're going to do is we're going to translate points, okay, in essence. So this is a simple example of it. If a graph of f passes through the point 2, 6, then the graph of g of x equals f of x plus 3 minus 5 will pass through what point? So let's first name our transformations based on what we see in our given equation here. This plus 3 is a transformation. It's going to move the graph left 3. Okay? And then the minus 5 out here is going to take my graph and move it down 5. So to move the graph left 3, that affects x. That takes the x coordinate and subtracts 3 from it. Down 5 means take the y coordinate and subtract 5 from it. So my point 2, 6, if it gets moved by these transformations, then I would have to take 2 and subtract 3, take 6 and subtract 5. So my new coordinate would be -1, 1. And this is the correct answer. So if f passes through 2, 6, then after I do these transformations, that point will move to -1, 1. And that's how we're going to work on graphing all of these functions that we get using transformations. Okay, all right, so let's go and try another example here. Oh, no, before that, let's talk about reflections again. So reflections, if to reflect over the x-axis means to multiply the y coordinates by -1. You can literally see it right here, negative y. F of x is just a fancy way to say y. This is really -1 times y, okay? And then to reflect over the y-axis, we talked about this earlier, multiply the x coordinates by -1. And you can flat out see it right here. You're taking the x and you're making it negative. You're taking -1 and multiplying it by x. Okay? Those are your reflections. All right, so now let's translate some points. Here we go. Here's my graph. Y equals -x plus 1 squared plus 4. That's what I want to graph. To graph these using transformations, the first thing you need to do is identify the parent graph. So you should have done this before. The parent graph is the graph of the function with no transformations on it. So if the graph had no transformations, what would it look like? This graph would just be y equals x squared. Okay? This negative out front, the +1 and the +4, all transform the graph in some way. So if you take all those away, you're left with y equals x squared. Y equals x squared is just a parabola that looks like that. We know that for certain. You need to know what all your parent graphs look like to be able to graph using this method. Okay, so now I need to identify some key points on the parent graph. So your key points are easy to identify. All you're going to do is you're going to take simple numbers like -1, 0, 1, whatever they may be, and you're going to substitute them in for x and figure out its y value. So for example, if I take -1 and I substitute it into y equals x squared, I would get -1 squared, that's 1. So there's one key point, -1, 1. If I take 0 and I substitute it in, 0 squared is 0. 0, 0 is another key point. If I take 1 and substitute it in, I get 1. 1, 1 is my third key point. Okay? These are the points that we're going to translate like we did in one of the previous slides, except I just gave you a point there. This time you have to figure out what the key points are to translate. All right? Now, let's go ahead and identify our transformations. You should notice, hopefully, that there are 3 transformations that need to be identified. The first one is this negative all the way out in the front. This is -1 times this. What is this doing? This is reflecting the graph over the x-axis. Okay, the negative's outside. If the negative were to be inside next to x, right next to x, then it would be a reflection over the y-axis. But it's outside here, so it's a reflection over the x-axis. That means I'm going to have to take the y values and multiply them by -1, okay, to reflect something over the x-axis. Number 2, this +1 moves the graph left 1. I'm going to take the x's and take 1 away. And the +4 moves the graph up 4. Take the y's and add 4. So now, what I want to do to my key points is the following. I actually want to use these transformations on the key points. So we're just going to kind of figure out what we're going to, our little formula cookbook here. We're going to take the x's and take 1 away. The y's, we're going to multiply them by -1 and then add 4. Okay, you can do them both in the same step. One shot. All right, so we got -1. -1 minus 1 is -2. Put 1 in for y, you get 3. If I put 0 in for x, I get -1. 0 in for y, I get 4. If I put 1 in for x, I get 0. If I put 1 in for y, I get 3. So I'm going to take these 3 points, I'm going to graph them. Up 3, make a point. Left 1 up 4, make a point. 0, 3. And I get a parabola. I know that because actually, where does the parent graph? That opens down. And that's the correct answer. Okay? You're done. That's it. All right? It takes a little bit of work, but it can be done. I promise you. All right, let's try another one. Same idea. G of x equals -2 minus square root of -x. Okay, first things first. This -2 is in the wrong spot. This -2 normally would appear in the back. So let's put it in the back. There we go. Now it looks hopefully a little bit easier to identify. Okay, let's talk about our parent graph. Our parent graph would be the graph with no transformations on it. So that negative does something, that negative does something, and that -2 does something. So y equals square root x is my parent graph. Simplest graph I can make. Okay, let's talk about the key points on y equals square root x. All right, so now we have an issue right off the bat. We can't take -1 and plug it in because we can't do the square root of -1. But we can do 0. Square root of 0 is 0. We can do 1. Square root of 1 is 1. And then I don't want to do square root 2 because I don't know what that is. It's some decimal. So I'm going to do a simple number like 4. Square root of 4, that's 2. There are my key points on the parent graph. Now let's identify our transformations. Let's go for those transformations. There are 3. That, and that are all going to do something. Okay? 3 transformations. This negative in the front is going to reflect the graph over the x-axis. Takes the y's, multiplies them by -1. This negative multiplying x is going to reflect over the y-axis. It's going to take the x's and multiply them by -1. Literally says that. The -2, down 2. All right. So now, that takes the y's and takes 2 away. So what am I going to do? I need to take the x's, multiply them by -1. The y's, I have to multiply them by -1 and take 2 away. Here we go. We're going to plug them in. If I take 0, put it in for x, I get 0. 0, put it in for y, -2. 1 in for x, -1. 1 in for y, -3. 4 in for x, -4. 2 in for y, -4. My parent graph, y equals square root x, normally looks like that. So we should get something that's similar to that, but it's going to be reflected a bunch of times, so we have to keep that in mind as well. So we got 0, -2, 1, -3, 2, 3, 4, -4, -4. So my graph looks like that. There's my graph. And you can kind of see how that would work. If you take this graph, reflect it over the x-axis, you get something that looks like that. And then if you reflected it over the y-axis, it would look something like that, right? So it looks like our graphs got the same shape going the correct direction. All right? So that's it for that one. Okay, let's go on to the stretching and the shrinking. A vertical stretch and a vertical shrink. Okay, you could take a graph and stretch it vertically away from or toward the x-axis if you take the function f of x, y, and multiply it by a, some number. If a is greater than 1, f stretches away from the x-axis by a factor of a. So for example, f of x is just y equals x squared. Okay, if I take 2 f of x, or 2x squared, if I double the points on f of x, okay, double the points on f of x, 1, 1, multiply the y coordinate by 2, becomes 1, 2. So it's stretching further away from the x-axis. If a is between 0 and 1, f comes toward the x-axis. right? So if I have 1/2 x squared, then I'm going to take this point and take half of it. So 2, 4 becomes 2, 2. It gets closer to the x-axis. All right, that's what we mean by vertical stretching and shrinking. Okay? All right, let's try another one. Here we go. We're going to graph this function h of x. -2. Quantity, x plus 1 cubed minus 4. Let's identify that parent graph. Okay, the negative does something, the 2 does something, the 1 does something, the -4 does something. So y equals x cubed is that parent. Y equals x cubed looks like that. Again, you have to know what your parent graphs look like to be able to graph in this form. Your key points for that. So again, we're going to plug in simple numbers. -1, plug it in. -1 cubed is -1. 0, plug it in, 0. 1, plug it in, 1. Our transformations. There are 4 transformations. This negative that's in front reflects the graph over the x-axis. It multiplies the y's by -1. Now, I do understand we're going to multiply y by -2, but this is one transformation. The 2 is another. The 2 is a vertical stretch. It takes the y's and multiplies them by 2. The +1 moves the graph left 1. Take the x's, take 1 away. And the -4 moves the graph down 4. Take the y's, take 4 away. Okay, so now we got a lot of work to do here. We need to take the x's, take 1 away. The y's, we need to multiply them by -1 and 2. So we can just multiply them by -2. But we had to separate them here because there were 2 different transformations. And then we're going to take 4 away. Okay, so where do we end up? -1 for x is -2. -1 for y is also -2. 0 for x, -1. 0 for y, -4. 1 for x, 0. 1 for y, -6. Left 2 down 2. Left 1 down 4. 0, -6. And my graph looks something like that. Okay, there's my graph. Similar to that x cubed graph, but it's been flipped over the x-axis. You can think about it like that. That'll help you to see where it's coming from. Okay? All right, finally, our horizontal stretch and shrink. So again, everything that's inside with x is kind of backwards and screwed up. If we stretch and shrink the graph horizontally away from or towards the y-axis, it's given by f of b times x. So here's the way that this works. If b is between 0 and 1, f stretches away from the y-axis by a factor of 1 over b. So now that sounds like a heck of a lot to say there, but here's what I mean, okay? Let's say, for example, down here on g of x, it's equal to the square root of 2 times x. So that means this will be, let's do this one down here. H of x is 0.5x. So that's the square root of 1/2 x, right? So what's happening here? This is going to be a horizontal stretch. Again, everything inside's backwards. Rather than multiplying the x's by 1/2, you multiply the x's by the reciprocal of 1/2. So you multiply the x's by 2. Okay? Multiply the x's by 2. All right, so that takes this distance and doubles it, moves it away from the y-axis. Okay? If b is greater than 1, it shrinks toward the y-axis by a factor of 1 over b. So if g of x is the square root of 2x, so this would be a horizontal shrink. You'd multiply x by the reciprocal, 1 over 2. All right, which moves the graph this way toward the y-axis. Okay? So look, it's the same concept no matter what. If I write the square root of 4x, you'd be multiplying x by 1/4. The square root of 1/3 x multiplies x by 3, the reciprocal of 1/3. All right, that's how this works. Again, everything inside with x is backward. Okay, last one. Here we go. J of x is equal to 3 times the square root of negative 2x plus 1. Let's identify that parent graph. So that parent graph is going to be y equals square root x. Looks like this. That's the parent graph. Okay, key points on the parent. 0, 0. I can't use any negatives for x. 1, 1. 4, 2. Those are my 3 easiest ones to use. There are 4 transformations up here. This 3 is a vertical stretch. It takes the y's and multiplies them by 3. The negative inside here is a transformation on its own. It's multiplying the x's by a negative. That's a reflection over the y-axis. Takes the x's, multiplies them by negative 1. The 2 is a horizontal shrink, but it's going to multiply the x's not by 2, by 1/2, by the reciprocal. Everything inside with x is kind of backward. And then the plus 1 is outside the square root, so this moves the graph up 1. Take the y's, add 1. So I'm going to take my x's, multiply them by negative 1/2. The negative 1 and the 1/2 do it at the same time. My y's, I am going to multiply by 3, add 1. So 0, 0, 0 times negative 1/2 is still 0. 0 in for y is 1. 1 in for x, negative 1/2. 1 in for y, 4. 4 in for x, negative 2. 2 in for y, 6, 1, 7. Make our graph 0, 1, negative 1/2, up 4, 1, 3, 4, negative 1/2 up 4, and then 2, 4, 5, 6, 7. And my graph now looks like that. That's the correct answer. And that's how you do this. Okay, it takes practice. We're going to be practicing a lot to make sure that you can do it. But this is how we want you to transform graphs, because they will start to get pretty complicated, but it works the same for every graph. You just have to know how to do it. All right, and as always, thanks for clicking.